couple of announcements before we start. First of all, we had 8 applications for grants this fall, which is substantially fewer than normal. Of those 8, we were able to award money to 6 of them for a total of $7,368. Just so you know, for the spring grant application cycle, which closes May 2nd, that'll leave us a total of $22,000 available for spring grants, which is basically the reverse of the way it's been over the last few years. So there's going to be a lot of money available for spring if you have any interest in a research grant. Maximum $2,500 per grant. The second thing I want to remind you of is our next lecture after today, which will be on February the 5th, Wednesday as usual at 4 p.m. That will feature Kay Bia Jones from architecture. Is Dr. Jones here?
No.
Don't see her here. Okay. In Mexico. Well, okay. But she's going to be talking on the following subject: beyond type, did Frank Lloyd Wright shape the modern architecture of Olivetti? Now, she should have quite the challenge, because my first question is, Olivetti, didn't he do typewriters or something? So I have no idea who Olivetti is, so I'll be very interested to hear that. So today we also want to recognize new members, which we do once a year or twice a year, Jackie? I can't even remember. Twice a year, yeah. So this fall's new members, we have 2 of them here in person and 2 up on the Zoom conference call. So, and 1 unable to attend. The one who's unable to attend will be Stuart Shapiro from the Department of Philosophy. Once again, we are very lucky to have Helen Malone here, who's our Vice Provost for Academic Policy and Faculty Resources. And she gets to make a few remarks to our incoming members. And then I will introduce them and she'll present the certificates. Helen?
Hi, everybody. Good afternoon. So thank you so much for the introduction. I made some notes just so I could get my data right. But first, our Emeritus Academy will be celebrating 10 years this year, which is great. One of the things I love about our academy is Penn State is setting up an Emeritus Academy, and they've modeled it directly after the work that you all have done in this space. So I take great pride when our colleagues in the Big Ten reach out and say, how do you honor your emeritus faculty? What are the steps that you take? And this is a point of pride for Ohio State that we have this academy. Here are the data that I thought were really great. So Ohio State has 108 tenure initiating units, and the Emeritus Academy has representation from 75 of those units. So that's a tremendous representation from our university. The other one I thought was really great is that there are currently 176 members. I think that includes our 5 new members, or maybe it's 181 now. But 90 of those have been participating for over 5 years. So this body allows our emeritus faculty an opportunity to continue to engage in their scholarship and creative activity, provide resources to continue that work, though I heard that we might have some fiscal work to do, and I will take that note back. And the opportunity to come together as a group. COVID converted this to a fully online format. It's lovely to be able to see you all in 3 dimensions, and also to have some of our colleagues be able to join us in a hybrid format. This space is where we moved a couple of years ago after the great work of Jackie and her team to identify a place where we could have an in-person event with some of our colleagues joining us online. So this is really a great organization. I enjoy working with this group, and I'm happy to be here to welcome our new members.
Thank you.
Yeah.
All right. So I'll go ahead and introduce the new members. Do we want to do on Zoom first? Let's do Zoom first. So up on Zoom, and I don't know if they're up there or not, but we'll look and see. From the Department of Plant Pathology in the College of Food, Agriculture, and Environmental Sciences is Ann Dorrance. And I don't know that we see everybody up there or not. The arrow, yeah. Are we able to show that, Jackie? Ann, are you there? If so, you can unmute yourself. Oh, there we go. Now we can see. No, okay. And then second, from the Department of Microbiology, the College of Arts and Sciences, is Tina Henkin. Tina,
I'm
hello.
here.
Congratulations to you too. And
Thank
we
you.
will get your certificate to you.
Thanks.
All right.
Hi, Tina. It's good to see you.
All right. In the room, though, I know we have two people attending. The first will be Tom Boyd from the Department of Neuroscience in the College of Medicine. Tom? Congratulations. And second will be Chuck Daniels from the Department of Microbiology in the College of Arts and Sciences. Chuck? And can we applause, congratulate them both? Thank you. Thanks.
No, you want to undo that.
Ardeen, you want to say something? There you go.
There's 27 newsletter items, so I'm having a time putting it all together, but I'll get it out to everyone soon.
Oh, I don't know if we can handle a delay in that newsletter.
Well, what can I say? 27 people this time.
As long as we're done by July with it, all right?
Okay.
Okay.
All right.
All right. So our talk today is by Ken Rinaldo, who is internationally recognized for interactive robotic and bio-art installations. His work develops hybrid ecologies with humans, machines, plants, animals, and more than human others by constructing idealized social, biological, and machine symbionts. And I have no idea what that means, but I'm looking forward to learning. His works focus on trans-species communication, animal agency, insect, bacterial, and emergent machine intelligence. Rinaldo's interactive robotic installations, animations, prints, and films have been commissioned by museums and galleries, with many in museum and private collections. His works have been featured at the National Museum of Art in Beijing, the New Art Fest Lisbon, World Ocean Museum in Russia, Ars Electronica Austria, the B3 Biennial, the Hermitage Museum in Russia, at the Hermitage, really. Boy, that's a cool place. Just like the Louvre. You know, honestly, that's a great place. If you ever get a chance to go, not now, but someday. The Peabody Essex Museum in the US, Platform 21 in Holland, Centro Nacional de Artes, Mexico. I don't speak Spanish, sorry. Transmedial Berlin, Arco Arts Festival in Spain, the Ulrich Museum of Art in the US, the Contemporary Arts Center in Winzavad, Russia, Centro Andaluz de Arts Spain, V2DEAF Holland, and the Itaú Museum Brazil. Pretty international. He's received commissions for new works from Nuit Blanche, Toronto. I do speak French. Vancouver Olympics, Te Papa Museum, New Zealand, Kiasma Museum, Finland, A-Life 16, Cancun, Mexico, Sunderland Museum, England, and the Lille International Arts Festival in France. His work appears in hundreds of books and art reviews while traveling to over 35 countries. He's received an award of distinction at Ars Electronica, first prize at VIDA, and a United Nations Greenleaf Award for the Farm Fountain. His works have been featured in Wired Magazine, the New York Times, CNET, BBC, CNN, CBC, as well as the Discovery Channel. Select publications such as Art and Electronic Media by Edward Schenken, Evolution Haute Couture, and Art and Science in the Post-Biological Age, edited by Russian curator Dmitry Bulatov, have featured his works. Ken, welcome.
And thank you all and welcome to this evening's presentation. Okay. So the AI art movement rides on the coattails of technical progress in computer vision, a research area dedicated to designing algorithms that can process meaningful visual information. A subclass of computer vision algorithms called generative models occupies center stage in this process. Generative models are artificial neural networks that can be trained on large data sets containing millions of images and learn to encode their statistically salient features. However, before that all began, there was AI and robotics. And this is where my adventure into artificial intelligence and robotics began as an interactive artist inspired by people like Rodney Brooks, who headed the MIT's AI lab at the time, and my own observations of living systems, which to this day remain my greatest inspiration. While the concept of an algorithmic species in relation to AI is not currently considered a scientific reality, some experts speculate that if AI continues to evolve with the capabilities like self-replication, adaptation, and complex learning, it could eventually be considered a new form of digital life that could be categorized as a species, especially if different AI systems begin to exhibit distinct characteristics and behaviors across populations. Okay, so let's see if this works. No. Slide, please. So the AI art movement, whoops, sorry. Thinking problems there. Today's AI systems are primarily designed to perform specific tasks based on their programming and training data, lacking the ability to independently evolve or reproduce in a way that resembles biological species. However, with the advancements of artificial general intelligence, AGI, where AI systems can learn and adapt across diverse domains, the potential for different species of AI could emerge, especially if they can interact and evolve within a simulated environment. Defining species in the context of AI raises complex philosophical questions about consciousness, sentience, and what constitutes life. As AI becomes more sophisticated, it could exhibit complex behaviors that mimic biological organisms, including things like learning, decision-making, and even social interactions. Advanced AI could potentially modify its own algorithms or code, leading to evolutionary adaptations over time. If multiple AI systems interact and compete with a digital environment, it could resemble an ecosystem with different species specializing in different niches. Next slide, please. As much current AI, there is a lack of physical embodiment. Unlike biological species, AI currently exists solely within digital systems lacking the physical characteristics and constraints that define biological evolution. That may change with the current pushes of places like Boston Dynamics and Amica, which is a cloud-connected platform that multiplies the power of artificial intelligence with an artificial body, where AI and machine learning can be tested and developed alongside engineered art's powerful tritium robot operating system. Still, we are talking about art here, and it is too important basically to be giving this over specifically to corporate interests. Plus, AI development remains heavily controlled by humans, which also limits the potential for independent evolution and non-anthropocentric species-like behavior. When we made the artificial robots of the flock, some of which you see here, we wanted 10 of them, which would lead to the next project. Next slide, please. Autopoiesis is an artificial life, artificial intelligence robotic series of 15 musical and robotic sculptures that interact with the public and modify their behaviors based on both the presence of the participants in the exhibition and the communication between each separate sculpture. They modified their code based on interaction with the viewers and themselves. Next slide, please. Autopoiesis breaks out of standard interfaces, the mouse and playback methodologies, the CRT, and it presents an interactive environment which is immersive, detailed, and able to evolve in real time by utilizing feedback and interaction from the audience participant members. They were inspired by the notion of the conscious plant, moving toward light, water, and other branches, exemplified in this case by the grapevines, which these were constructed with. Next slide, please. Two of the robots had micro video cameras on the tips of the arms, allowing you to see the perspective of this artificial life, artificially intelligent creature. Next slide, please.
Autopoiesis is an artificial
That should be. Let that run.
Autopoiesis is an artificial life robotic sculpture series commissioned by the Kiasma Museum in Helsinki, Finland. It consists of 15 musical and robotic sculptures that interact with the public and modify their behaviors based on both the presence of the participants in the exhibition and the communication between each separate sculpture. This series of robotic sculptures talk with each other through a hardwired network and audible telephone tones, which are a musical language for the group. The interactivity engages the viewer participant, who in turn affects the system's evolution and emergence. This creates a system evolution as well as an overall group sculptural aesthetic. Autopoiesis utilizes a number of unique approaches to create this complex and evolving environment. It uses smart sensor organization that senses the presence of the viewer participant and allows the robotic sculpture to respond intelligently. By organizing the sensors in this way, I have minimized the number of sensors while maximizing the ability of the software to cope with this data. For example, at the top of each sculptural element or arm, 4 passive infrared sensors face south, north, east, and west. When 2 sensors are triggered, the program knows that someone is located in, for instance, the southeast corner, and this is the direction the sculpture moves to. 4 sensors allow 8 quadrants of sensing.
Please.
These passive infrared sensors tell each.
The next work I'd like to show you is called the augmented fish reality, and I wanted to say seeing humans interact with robots and reading about the intelligence of fish, I was curious, could you create a robot that would actually be controlled by a series of Siamese fighting fish? So this is called the augmented fish reality, and it comprises 5 rolling robotic fish bowls designed to explore interspecies and transspecies communication. In these artificially intelligent mechanical sculptures, Siamese fighting fish use the robotic hardware and software to move their fish bowls anywhere they desire, demonstrating a hybrid self-organized learning. Next slide, please. By moving about, they choose to interact with their environment and other Siamese fighting fish. These Siamese fighting fish can also see clearly beyond their glass bowls in control of their individual fish cars. And speaking of fish intelligence, in an article by Dr. Cullen Brown and Jens Krauss, they discuss revisions in thinking about fish intelligence, which seems far more significant than was formerly imagined. It is now believed that fish are steeped in social intelligence. The article reports that fish will actually pursue a Machiavellian strategy of manipulation, punishment, and reconciliation, while displaying cultural traditions and cooperation to elude predators and obtain food. Next slide, please.
Augmented Fish Reality is an interactive installation of 5 rolling robotic fishbowl sculptures designed to explore interspecies and transspecies communication. These sculptures allow the Siamese fighting fish to use intelligent hardware and software to move their robotic bowls under their control. As with many fish, Siamese fighting fish have eyes which allow them to see for great distances outside the water. Fish have the ability to mentally map their environments in finding food and avoiding predators. This design uses 4 infrared sensors around each bowl, which allow the fish to move forward and back and turn the bowls. By swimming to the edge of the bowl, the fish activate motorized wheels that move the robots in that direction.
This was full speed for the robots, by the way. They moved very slowly and they had foam wheels
Humans
to
interact with
protect
the work simply
the
by
fish.
entering the environment. These bowls consist of a living environment of peace lilies which help to absorb the waste stream from the fish. The bowls and robots are designed to allow the fish to get within 1/4 inch of each other for visual communication between the fish, both male and female.
Next slide, please. So some have questioned whether or not fish have the intelligence for such things, and this pretty much confirmed it. Could you play that video, please? Oh, that's one back. Yeah. Well, if the video was playing, you would be seeing synchronized swimming of goldfish, which are quite extraordinary, and also considered some of the smartest fish on the planet. Oh, there we go. Well, that's weird. It's playing on my screen, but not on that one. Okay, well, let's just go ahead and skip then. Next slide, please. One of the things that we know about life is that life can give rise to itself. For me as an artist, this begged the question, if given the proper instructions, could a series of artificially intelligent swarm robots be born on a machine? Given the proper instructions. The autotelematic spider bots is an interactive artificial life or artificially intelligent robotic installation, and it's a collection of 10 spider-like sculptures. These sculptures engage with the public in real time, self-modifying their behaviors based on their interactions with the viewer, themselves, and their environment, and their food source. They were experiments in allowing a robot to emerge into energy autonomy by making it able to find its own recharge stations and communicate that back to others. So this was a 3D model of the robot, which was fully designed as a 3D model. Next slide, please. And this is what the exhibition looked like when it opened. And basically, it was a collaboration with myself and one of my former students, Matt Howard. And it's considered artificial life or AI robotic installation. And you can see it was a fairly big opening. And I think my mom's on the Zoom call right now, and she's somewhere in this audience. So, hi, Mom. So here's another shot of some of the spiders. And I have a video, a very short video here produced by, this is one of the, next slide, please, and next slide, and next slide, please, next slide, please, and next slide, please. This is one of the robots standing at the recharge station and connecting. And one of the very exciting things for me with this project was discovering something called self-healing fuses, which were a kind of polycrystalline silicon that would heal itself if people touched the two recharged tentacles together. And this for me was a kind of weird sense of a kind of artificial life. Next slide, please. And the spiders could communicate with Bluetooth about where the recharge station was, but because they were like spiders and ants, there was also a kind of a screen. And one of the spiders actually had a very small camera with the ability to project what it was seeing to the screen, as if you were caught in the web of these artificial intelligent creatures. Next slide, please. And next slide, please. Next slide, please. This was a map of their behaviors. And next slide, please. And you can let that play. I think the project really came to an exciting fruition when I saw this very exciting paper by a doctor of entomology, Dr. Guy Thériault, and he said basically that ants were rule-driven systems. And I realized at that moment that, well, if that's the case, knowing that
computers are in fact rule-driven systems, could you create a series of autonomous robots that would be able to act like ants? So in essence, what you have is you have a series of robots that roughly look like spiders, that seek out their food like ants, but that see like bats. As with spiders, they have multiple eyes. In this case, these spiders have infrared eyes that are sending out a pulse of infrared light and looking for a frequency back. If you actually look at the robots, you'll see at the front of the robots, there's a couple of springs right here. And as with a spider, the chelicerae of the spider brings the food into the mouth of the spider. Well, these are the chelicerae of the robot. And what happens is when the robot approaches a recharge station, it then connects between these two rails and then charges the battery up. They all talk with each other with Bluetooth, the communications technology. One of them can find a food source, for example, and it can then sing its food source back to the others with this Bluetooth communications, and then tell them where that food source is. There's a whole evolution happening within the realm of computing and technology, which is very much about somehow giving back emotional feedback to humans, because of course as humans we communicate with body languages and emotional responses and so on. For example, when you approach these robots and they see you, they twitter to you and they give you an emotional response, and you know instantly that they see you because they look right at you with these ultrasonic sensors that in fact look like eyes. I'm really fascinated by living systems and by the models that living systems provide to the technological world. I believe that there's an evolved wisdom to those models that, what they say maybe close to 4 billion years now life has been evolving. That's a very long time, but of course with technological systems they're moving so intense and so rapidly. In essence, we were actually able to evolve something through the use of visualization technology, 3D modeling, rapid prototyping to output what it was we thought we were seeing virtually and do they work physically given the materials. We were able to evolve the morphology literally in a matter of a couple of months. Of course, there are concerns with that as well, because in a biological world, everything is symbiotically intertwined. In our technological world, things don't get to intertwine as much. So a lot of my work is about trying to find a kind of gentle connection between the organic and the biological, and seeing if in fact we can, in considering those lessons that the biological offers us, if we can in fact allow the technological systems and the biological to be better coupled, to be symbiotically intertwined to some extent.
Next slide, please. Inspired by swarms, I became very excited by the microbiome. And what you're looking at right here is a robot called the enteric consciousness. Next slide, please. Let me try to sync up my slides here. So the enteric consciousness is an interactive installation focused on our conscious microbiome in each of our stomachs. And it's interested in this magical digestion and their consciousness and ours creating that together. Our stomachs are considered the enteric nervous system, which is embedded in the lining of the gastrointestinal system. Our natural stomachs, or the enteric nervous system, have 1/10 the number of neurons in the human brain and share the same neurotransmitters such as dopamine, serotonin, and epinephrine. However, they process the experience differently than the brain. Let's see, next slide, please. And here you'll see an image of the robotic chair. Your body is home to trillions upon trillions of bacteria. Your body is about 10 trillion cells, but harbor 100 trillion bacteria. For every gene in your genome, there are 100 bacterial ones. This is your microbiome, and it dramatically impacts your health and ability to digest food. We in turn affect them, and they in turn affect us. Next slide, please. And this is the artificial stomach. It's a robotic tongue chair, as I mentioned, but this is the stomach that holds the bacteria. Next slide, please. This is me getting my 15-minute massage. When I think about the human brain, I like to think that the hands are the extension of the brain. But if I think about the brain in the stomach, it's the tongue that is the extension of that brain. And that's a brain that knows what it likes to eat, things like fat and chocolate and such. Next slide, please. Next slide, please.
The entire consciousness is a large robotic tongue controlled by an artificial stomach. This artificial stomach is filled with the same living bacteria, Lactobacillus acidophilus, that occupy our own natural stomachs. Our stomachs and intestinal systems are called the enteric nervous system and are certainly seen as forms of intelligence, as they possess 1/1000th of the numbers of neurons in the human brain and use many of the same neurotransmitters such as dopamine, serotonin, and epinephrine. If the hand and finger can be seen as extensions of our human brain, then the tongue can be thought of as an extension of the enteric nervous system, seeking out what it prefers to ingest. In this installation, an artificial stomach will allow the bacteria within it to activate a functioning robotic chair in the shape of a giant tongue. This giant tongue is designed to give you a comforting massage. The robotic chair is covered with a red emu leather that gives the appearance of swollen taste buds of an enlarged and hungry tongue. I have chosen in this work to focus on our sense of touch and corporeal experience as a way to explore interactivity, as our largest sense organ is in fact our skin. As peristaltic muscle movements propel food and bacteria through our natural stomachs, so an electronic peristaltic pump will artificially replicate these movements as it moves cooling water through the artificial glass stomach. A pH meter will constantly measure the acidity and basicity of the bacteria, and these signals are interfaced to and activate a series of relays and microcontrollers that allow the robotic tongue chair to activate, relax, and massage the viewer interactant. Acid-loving milk bacterium, Lactobacillus acidophilus, are the activators of this robotic tongue. Another important element of this installation are two smaller robotic tongues that dip into and out of chocolate pools located in large glass containers. The containers are held up by large dopamine molecules constructed in steel. The dopamine molecule is believed to mediate the subjective experience of pleasure in humans and other animals. Sugar and fat are two substances that both the tongue and the stomach desire. Research has proven that chocolate can boost serotonin, and it can also stimulate secretions of endorphins. This work is mostly inspired by the notion of the conscious stomach, though it is also inspired by the ideas that humans are not individuals so much as clouds of intertwined human, bacterial, and now machine cells. We have evolved into hybrid symbiotic ecosystems that consist of trillions of living bacteria.
So speaking of evolution and
The
technology.
entire consciousness is a large...
Next slide, please. And next slide, please.
robotic tongue.
Okay, so speaking of the evolution of humans and machines, the paparazzi bots are a series of 5 artificially intelligent autonomous robots, each standing at the average human height. They're comprised of multiple microprocessors, cameras, sensors, code, and robotic actuators on a custom-built rolling platform. They move at the speed of the walking human, avoiding walls and obstacles while using sensors to move toward humans. Next slide, please. And let's see. Next slide, please.
The paparazzi bots are a series of 5 autonomous robots, each standing at the height of the average human. Comprised of multiple cameras, sensors, and robotic actuators on a custom-built rolling platform, they move at the speed of a walking human, avoiding walls and obstacles while using infrared sensors to move toward humans. They have ultrasonic sensors allowing them to see out to a distance of 13 feet in order to move toward passing subjects. The paparazzi robots seek one thing, which is to capture photos of people and to make these images available to the press and the World Wide Web as a statement of culture's obsession with the celebrity image, and especially our own images. Each autonomous robot makes the decision to take the photos of particular people while ignoring other humans in the exhibition, based on such things as whether or not the viewers are smiling or the shape of their smile. When the robots identify a person or group, they automatically adjust their focus, and the robots stop and use a series of bright flashes to record that moment. For exhibitions, the robots are placed in a low wooden ring with red carpet to stage our associations to VIP events. The bling of the multiple flashes, capturing people's photos and elevating them to celebrity, becomes a kind of momentary anointing by the robots. The robots also become celebrities through their association to the famous people at the exhibition that are captured by the robots. This interactive robotic installation also features a micro-video transceiver wired through the camera, which allows you to see the artificial eyes of the camera as it tracks your head and smile. These images are sent via a 2.4 gigahertz transmitter to a receiver connected to a video projector, and the images captured are then projected to screens which reside in the installation. This further elevates individuals in the installation to feeling acknowledged by the robots. Surveillance technologies straddle a delicate balance that we have in contemporary culture, where we are all photographed without our knowledge by cell phones, hidden cameras, and sometimes we are celebritized. This is a kind of modern machine baptism, with the camera flash and the spectacle of being the focus of the camera becoming a kind of techno-anointing. The recent emergence of social networks and their ability to connect people through software prompts via the World Wide Web is a prime example of the co-evolution of humans and their intelligent machines. This work explores ideas surrounding these shifting territories of self and machine, and how machines can often manipulate the other, us, in a grand co-evolutionary dance of emerging robot-human relationships.
So next slide, please. Next slide, please. Next slide, please. So these are some shots from various exhibitions around the world. Next slide, please. Next, please. Next, please. These were taken at the Eaton Mall in Canada. Next slide, please. Next slide, please. Some of my favorite shots are actually often the ones that are accidental movement shots. Next slide, please. This is one of my favorites. Next slide, please. And next, please. Next, please. Next. Next, please. This was at the Vancouver Olympics, where I was actually given, how would you say, I won a medal, cultural Olympian, which was quite an honor. Next slide, please. Next slide, please. Next, please. Next, please. Next, and next, and next, and next. Next slide, please. So the next work I'd like to show you is a work concerned about the environment. And let me catch up here on my slides. Okay. So this, perhaps one of the greatest tragedies of our time with global industrial farming, habitat loss, and global warming, deforestation, and synthetic pesticide use, is the recent realization we are in the middle of an insect apocalypse. Next slide, please. A 2017, 27-year-long population monitoring study revealed a 76% decline in flying insects alone, which will provoke a cascading effect on food webs and, we know, jeopardize ecosystems, including our own. Next slide, please. As insects are at the base of the food chain and are critical to pollination, this is a truly global tragedy for implications for the environment beyond the human food systems. Next slide, please. And let's see. So the opera for dying insects, next slide, please, is a sound and video work which wishes to address this issue with an opera that is auto-composed by insects eating a moist log. Next slide, please. And you can let this run.
Perhaps one of the greatest tragedies of our time is the recent realization that we are in the middle of an insect apocalypse, resulting from industrialized farming, habitat loss, global warming, deforestation, and synthetic pesticide use. 73 separate studies estimate that insects have declined by 41% since scientists have been tracking their populations. In 2017, a 27-year-long population monitoring study revealed a 76% decline in flying insects alone. Insects are disappearing by 2.5% yearly, and 40% of insect species are near extinction. As insects comprise the base of the food chain for other species, such as birds, this is a truly global tragedy that has implications for the food chain beyond human food systems. For humans, 3/4 of our crops depend on insect pollination. Living isopods, or pillbugs, are voicing this tragedy through their activities in this biorobotic artwork, The Opera for Dying Insects. The opera remix is composed as they slowly eat, deconstruct, and reproduce in their green vitrine, a protected paradise of moist mosses. The isopod's movements are sensed with AI software, and the video is analyzed to determine their location, number, and speed of movement. As music evokes deep emotional responses, tragic opera seems the ideal way to help humans understand the global tragedy before us. When this work is installed, people can observe the living environment and large live images projected onto the wall of the installation to reveal this micro-world at a scale equivalent to our own. These videos are mixed with videos of industrial farming, pesticide use, and other industrial processes decimating insects globally. This work invites us to notice the subtlety and the beauty of all insects, as well as ancient isopods. As isopods have survived multiple global extinction events, they are the ideal musical activators of this tragic opera. With this biorobotic installation, we may also realize that a catastrophic collapse of nature's ecosystems will mean unprecedented human hunger and perhaps our own extinction.
Next slide, please. The next work I'd like to show you is called fusiform polyphony, or face music. Some of you probably know about the fusiform gyrus, which is a part of the brain that recognizes faces in particular. In this case, this is a series of 6 robotic, artificially intelligent soft robots that were commissioned by Nuit Blanche in Toronto, curated by a curator named Shirley Medill. Fusiform polyphony composes music with input from participants' facial images. It is important to say, when I asked engineers about a robot approaching people's faces to take their snapshots, they pretty much just laughed at me like, are you kidding me? You're going to swipe somebody's head off. But, you know, as with a lot of artists, we're undeterred. If somebody says no, we generally try to move forward anyway. And thus is the invention of this new work, face music. Next slide, please. These are some shots of the opening, easily my largest opening to date. At any one time, there were maybe 50,000 people in the Young Dundas Square. At the same time, I was fortunate I had a graduate student that was watching the paparazzi bots at the Eaton Mall, which was nearby on 2 different floors. And so I spent most of my time in the young Dundas Square watching over this work. Next slide, please. And let's see, next slide, please. And next slide, please. Here's somebody getting her shot taken. Next slide, please. And next slide, please. Let's see if we're synced up here. Next slide, please. And next slide, please. And next slide, please. And next slide, please.
Fusiform Polyphony is a series of 6 interactive robotic sculptures that compose their own music with input from participant facial images. Micro-video cameras mounted on the ends of these robots move toward people's body heat and faces while capturing human snapshots. These images are digitally processed, pixelated, and produce constantly evolving generative soundscapes where facial features and interaction are turned into sound, melody, tone, and rhythm. These elements fused manifest the viewer as participant, actor, and conductor in defining new ways of interacting with robots and allow the robots to safely interact with humans in complex and natural environments. An important element of this installation is to see self through the robot's artificial eyes, as each robot tracks and captures images in the process of showing the nature of algorithmic robotic vision. These works are covered in human hair and explore new morphologies of soft robotics, an emerging field where natural materials make the works approachable and friendly. The hair serves to point to a human-robotic hybrid moment in our own evolution, where the intelligence of robots is more fully fusing with our own. The live camera-based video of the robots is processed through Max MSP and Jitter and projected to the periphery of the installation on 5 screens. When the robot is at head height, a sensor at the tip of the robot is triggered and a facial snapshot is taken. The snapshot is held in the small area of the projected screen to the upper right. That snapshot is broken down into 300 pixel grid, and variations of red, green, and blue data of each pixel is extracted and interfaced to Max MSP and Jitter and to Ableton Live, which selects the musical sample determining rhythm, tempo, and dynamics. Changing pixel data constantly changes Ableton virtual instrument selection sets with random seed.
Next slide, please.
Fusiform Polyphony is a series of 6 interactive robotic sculptures that compose their own music with input from participant facial images. Micro-video cameras mounted on the ends of these robots move toward...
Can you go to the next slide? Yeah, thank you. All right. So I also work perhaps more traditionally with 3D prints and hand-drawn works, as well as manipulated photo data. While at a residency in Mexico, I took photos of birds and butterflies in the city of Cholula, Cancun, and Coapa to allow the data to become color and form. The photos' color and light-dark values were imported into 3D software and manipulated to create abstractions of the stunning living colors of Mexico. These are basically data-based works which demonstrate different approaches to software and utilizing camera data instead of just pure photographic images. Next slide, please. As a result, the manipulations allow the suggestions of the photo, though not a clear representation as to what was being photographed. Next slide, please. And next slide, please. And next slide, please. And next slide, please. And next slide, please. Next slide, please. And let me catch up with you here. So playing with so many robotic designs and schematics, I also see beauty in schematic designs. And these are hand-drawn works from what I call the sacs, membranes, motors, and vesicles series, where established biological networks come together with powerful information and machine networks. Exploded diagrams illustrate the functional organs of biological and machine systems co-evolving together. Next slide, please. These works are diagrams of an emergent systems evolution created when the microbes and vesicles of cells enter the technology, absorb it, and get enveloped by it. Intertwining elements enter each other and become part of the flow and process of consumer, consumption, and waste cycles. Next slide, please. Sacs refer to small sac-like structures within cells or within larger cellular structures. Next slide, please. These can include lysosomes, which contain digestive enzymes, or peroxisomes involved in metabolic processes. Membranes, as many of you know, are thin layers of lipid and proteins that surround cells and cell organelles. Next slide, please. There are also machine entities that convert chemical energy for transport of humans and goods. Vesicles are small membrane-bound structures that serve as a means of transport within, such as proteins and lipids. Next slide, please. Next slide, please. So basically, when I started playing with a lot of artificially intelligent software, one of my biggest frustrations was that everything came out to look like a human, often cute girls and guys with perfect hair. That really annoyed me. And I thought that maybe I could come up with something a little bit more interesting by using my own drawings as a training set. And so what I did was I took my drawings and the words that those drawings gave me, or I associated with those drawings. The drawings, by the way, were automatist drawings, meaning I was just sort of letting my hand go and then coloring them in, adding color, adding new elements. I would feed those to a large language model that could take my drawings. That would suggest a phrase or a word, and then I would let the large language model further evolve my drawings. When these were presented at an exhibition back in 2022 at a gallery that carries my work in Lisbon, Portugal, we framed them all together, basically. And so the one on the lower left is my hand-drawn work, and the one on the right is the AI-generated work. Next slide, please. And next slide, please. This one you could see is called Kinesin descending a Cat6 cable. And that would be a joke, I guess, on Duchamp's a woman descending a staircase. Most of you probably know what a Cat6 cable is. Next slide, please. And part of the exhibition was also to show my hand-drawn works being evolved by the AI. And if you could go ahead and play that, please. And the music was also composed by AI in this next work. So it starts off with my hand-drawn works, and then they morph over time into many elements that suggested by the World Wide Web. So the words basically would pull up images, but it was basically a conflation between my images and my imagery, and then what the words would then tell the AI to associate with my imagery. You'll notice that the AIs are always trying to create human form, of course, because most or much of the training data from large language models is coming from photographers primarily focused on human forms, which is of course why things like Midjourney and DALL-E are so good at reproducing human forms, regretfully often with 6 fingers and hands for toes and feet. But that's kind of funny for me, quite frankly. But I'm more interested in abstractions and playing and pushing on the technology. When I was teaching at Ohio State University, I would often tell the students, the best use of the tools is a misuse of the tools. If you use the tools as intended, you'll end up with results that look like everybody else's. For me, many of these are quite suggestive. demonstrative of very large amounts of data versus direct interactive works that are also considered AI, but really more of the early days of AI back in 1994 and the year 2000, before large language models and generative AI were really becoming the thing. Here you can see the abstraction is really trying so hard to make something figurative. I think the words I was using here as a suggested word were human insect cyborgs. Sort of see some of the suggestions of wings and things of that nature. Almost looked like a football helmet, but I promise you I said nothing about Ohio State's Buckeyes. Next slide, please. And this is one of the last works I'll show. Basically, this is a, let's see if I can get on the same slide as you're on. This is called the CRISPR seed resurrection. And it's basically a piece that's interested in trying to develop seeds that will bloom in a distant future, where the Earth continues to warm. The idea is to use CRISPR to manipulate the seeds and put them in these large seeds, which would be eaten by ducks and spread around the planet. Next slide, please. And these ducks would then spread these around the planet, including airplanes, and have these bloom in a distant future to reseed the Earth. So it's the idea here was to use CRISPR technology. Many of you understand what CRISPR is. Basically, it's the ability to manipulate DNA and change various aspects of that DNA, basically to genetically engineer something with very accurate scissors. Next slide, please. And next slide, please. And next slide, please. And next slide, please. Next slide, please. Next slide, please. Let's see. So this is the genetic traits that will be modified in the CRISPR process, where the respiratory burst oxidase homolog D senescence associated gene 113 and ORISARA1. Next slide, please. Other genes to extend the life of the seed and introduce seed dormancy may be achieved with the gene called the Hansu, named after the Korean word meaning abnormal drowsiness. Next slide, please. And next slide, please. And I believe that there's a video here. Let's see. Next slide, please. When you stood in front of the mic, this was the song that was sung about the work. You'll see it consists of garbage cans.
We expel black and CO2. We saturate your air with toxic molecules. Ice caps are melting too. Acidifying, warming up. Our ocean body steams. Our forests are burning, and so are our dreams. We endow a sophistication of bacteria fighting a virus. Genes changed will rearrange, allowing you to teach us. We annotate and assemble DNA of future seeds that may, if we need, bloom, boom, and succeed. We can use evolution to change evolution. CRISPR,
Performed by Trademark Anderson against
we use evolution to
sometimes
change evolution.
next slide, please.
CRISPR, shine.
And I think I'd like to just end my presentation by showing some quick visualizations. This is a piece that was recently funded by the Emeritus Academy. I thank you very much. Next slide, please. Next slide, please. Next slide, please. And next slide, please. And this is an installation that is a celebration of Lynn Margulis, one of my heroes, Carl Sagan, who was the husband of Lynn Margulis. And it's an installation basically that will involve these very large mitochondria cut in half, which will be speaking a kind of AI conflation of Lynn Margulis and Carl Sagan's philosophies. Next slide, please. And this is the process of producing some of the glass. Next slide, please. This is the process of producing some of the molecules once the glass is cut in half. Next slide, please. Me embedding the speaker, the Bluetooth speaker, after deconstructing the speaker. I do a lot of hacking in my business. Next slide, please. And let's see, next slide, please. This is what one of them looks like after they've been put in their glass containers, showing the cristae.
So I'm sure we have a few minutes available for questions. If you have one, just put up your hand and I'll run a microphone to you. Carl, that is you back there.
Thank you. Did your work have to undergo, or you have to undergo any security clearance to go into Moscow?
Right now, if they should be by plane, actually got stuck in customs. And so no, it didn't go, it never got into the country in time for the exhibition. So it actually ended up premiering in Germany instead. But no, I've not had problems getting the works in through customs. It had more to do with a missing stamp and perhaps some money that somebody wanted that I wasn't able to produce to get the work into Moscow. But I've shown quite a bit in Russia, and I've never really had any problems. I guess I'm fortunate to have gotten to work with really great curators, and it's a fairly wonderful community of people. Actually,
Yeah, my experience is if you have a sponsor
yes,
over there that's invited you over and they work for the state a lot of times,
yes,
then you don't have a problem.
yeah.
Other questions?
I thought this was a totally fascinating lecture.
Well,
Thank you so much.
Thank you so much.
I'm curious about your use of the word feeding. When you talk about the spider bots, which I do think are gloriously formed. Of all the things you've done, they're the ones that appeal to me. But you talk about charging, and I thought, well, maybe that's feeding. But no, you talk about feeding, and foraging appears on your diagram.
Yeah,
What's the feeding?
the feeding was the recharge station.
Oh, it was the recharge
It was the
station.
recharge station, and the foraging was the behavior of them looking for the recharge station. I used a Roomba vacuum cleaner beacon underneath the recharge station, and then I used 2 door transoms out of metal separated by wood so that when I think I'm pronouncing it wrong, when the chelicerae, I think it is, attached to, if anybody's in here and studies insects, would attach to the recharge station, it would charge them up, basically.
Thank you very much.
You're welcome. Yes.
I was curious about your references to the use of data, and I would assume or stereotype what I associate AI with is myriads and myriads and myriads of data that would require huge amounts of storage as a resource. And I wonder what you can tell us about where your data is stored and how you retrieve it.
Yeah, well, this was maybe a little bit of a trip down memory lane, because back in the early 90s, data was just on the robots. When Rodney Brooks was at MIT, for example, running their AI lab, he was using a form of software called subsumption architecture. That in its day was like cutting edge. And all he said was, well, we don't really want robots to be like, there was another guy at Carnegie Mellon University named Red Whitaker. They called him Big Red. And he had these big robots and they would say, okay, I'm taking an image of the world, I'm storing an image of the world. And the thing would then march forward at like a mile a second. Oh, it found something. The world's changed. I'm taking another image of the world. And then the robot would march forward. Now that was a robot that had big memory banks and it was this big. Then Rodney Brooks came along and he said, wait, the world is always changing. Know what the world is. We just need to know what it is after it changes. Quick up with this architecture called subsumption architecture. And a lot of my robots were based on that notion, which is that the world's always changing. You don't need to store a lot of data, even though some of them did use very complex microchips, like in the day, silicon graphics, SGI microchips were used in the flock piece, which was flocking towards sound. But basically, the latest works, the ones that were the imaging works, those are using very large data, and those are being stored regretfully in very large data centers around the country. And those are involving probably millions of photographs that are associating the words of those particular pieces with the images and or the words I'm using to pull those images up. So I'm not storing any of it. It's all being stored by probably Amazon's cloud services would be my guess.
Interest AWS maybe.
That's the data.
Thank you. Thank you very much.
Let me ask one a little farther on that. And this is obviously asking from a point of ignorance, kind of like a smart spider. A lot of data, and you program these robots, but you're talking about using large language models and generative AI. So are these robots programmed to do what they're doing, or is it like the new forms of the language models for foreign language interpretation where they're learning on the job, or the new chess programs where they're not being algorithmically programmed to play chess, but they're learning how to play chess in their own time and get better and better? So are these robots learning as they go, or is it all pre-programmed in?
They're, in a sense, they are learning, but if you, at the very earliest works, those would be the most primitive, basically.
Sure.
And those would be what you would basically call attraction repulsion robots. They would move towards certain things they wanted to see. But in a way, I think part of the challenge is that we often think of intelligence as being solely to ourselves or the individual, but intelligence is in the environment. It's everywhere we go. In a way, everything we do is programmed by moving through the world, and the intelligence is external to the thing. So for example, with autopoiesis, it was learning the environment, but its learning was based on this idea, again, of Rodney Brooks. He called it subsumption architecture. So it was a kind of layered approach to behavior. So they would say their behavior was, okay, right now there's nobody in the environment, move as a single organism. And they were moving as an organism. Okay, somebody has entered over here, pull from the group and stop moving as an organism and move as an individual. Pay attention what's happening locally. So the structure of the program itself was logically created to respond to whatever was happening locally. So in a way, it's a similar thing with our own bodies. Like we're a kind of subsumption architecture unto ourselves. We've got a reptilian brain. You know, you can put your hand over a fire and you'll pull your hand away from the fire even before the signal gets to your brain. Body is already feeling the heat of the fire. So in a way, it's kind of a similar sort of analogy.
Thank you.
I hope I answered your question.
Other questions? We're good. Thank you so much for a fascinating presentation today.
Thank you.
All right.
Nice to meet you all.